Ballistics. Ballistics is the maths behind the launching and behavior of a projectile. Whether it be a bullet, rock, spear, or even a rocket, these are precisely calculated and observed with ballistics. Knowing this allows us to exactly calculate the distance, speed, and trajectory a given projectile will travel in. To begin with, we have a parabola. This is the shape a projectile given no resistance will travel. It doesn't matter how fast or slow it's going, if gravity has an effect on the object, then it will fall in a parabolic shape. So to start, we have a demonstration. This is a 5.56 by 45mm, or just 5.56, rifle round. The 5.56 bullet is commonly seen in M16 and M4 assault rifles. Inside an M16, a 5.56 round will achieve a speed between 900 and 950 meters per second. We'll be doing a theoretical test on paper, and then we'll move on to a test inside a simulation to see if we're correct. However, neither the theoretical or simulation will factor in wind resistance. To begin with, a projectile's speed, or muzzle velocity, is how fast the projectile will travel once it reaches the end of the barrel. To calculate how far the projectile will move, you need to divide the speed into two axes, the x and the y-axis. The x-axis determines how far the projectile will travel. The speed of the projectile on the x-axis always stays constant. This basically means that if the bullet is traveling on the x-axis at 500 meters per second and stays in the air for 1 second, then the bullet would have traveled 500 meters, as the speed on the x-axis is always the same. To determine how long the bullet stays in the air, we need its vertical speed at the muzzle. This is divided by the gravity, g, or 9.81 meters per second, to give time. For instance, if the bullet is moving 50 meters per second upwards, it will take 50 divided by 9.81 seconds to reach the apex and the same amount of time to reach the ground. This means it would reach its apex in 5.09 seconds and reach the ground in 10.19 seconds. Using this, we can determine how far the bullet will go on the x-axis. If the bullet is moving 800 meters per second laterally and stays in the air for 10 seconds, it will go 8,000 meters. Onto the simulation. The bullet in the simulation moves 920 meters per second, meaning that if aimed at 45 degrees, it will move 460 meters per second upwards and 460 meters per second sideways. However, we won't be aiming at 45 degrees. We will be trying to hit a target 2,000 meters away, meaning that we need to determine the angle we need to fire at to hit the target. So knowing that the target is 2,000 meters away, we must consequently aim at either A degrees or B degrees, A being under 45 degrees and B being above 45 degrees. We will first determine A degrees because the total time the bullet is in the air is much lower than B degrees. Then, all we need to do is put in all the variables into the ballistic formula. This being theta, the angle, is equal to half arcsine of distance times the gravity over the speed squared. This may seem difficult, but all we need here is substitution. So, because we are trying to determine the angle we need to fire at, we need to substitute the other values in to find it. This means we end up with half arcsine of 2000, distance, times 9.81, which is gravity, over 920 squared. This gives us 0 degrees, 39 minutes, and 50.88 seconds, meaning we have to aim above the target about 2/3 of a degree. So, aim up 2/3 of a degree, and direct hit. In conclusion, to accurately fire weapons at a distance, maths comes in very handy. The ballistic formula is used in many different fields and is useful in determining how fast something will go.